Hello everyone, I am Han Yingche from Institute of Data Science and Knowledge Engineering, School of Computer Science in Beijing Institute of Technology. In this session, we will discuss about what is No SQL DataBase. The big data computing system can be summarized into three categories: data storing system, data processing system, data application. The data storage architecture is the foundation of big data computing. In data storing system, there are four paths to accomplish different tasks, which is data collection and modeling, distributed file system, distributed database, data warehouse, and unified data access interface. We learned data collection and modeling, distributed file system already. Now, we look at database. Database normally include relational database like Oracle, SQL Server, etc., and also NoSQL database like MongoDB, HBase, etc. The distributed database and data warehouse built on the file system not only realize the storage management of data, but more importantly, it supports the fast data query function and the data analysis service of the upper computing engine and application software. Currently, there are many types of database products that support big data applications, and their storage structure and technologies used are also different. Relational database RDBMS has always been the mainstream of data storage management system with its good data consistency, complete transaction mechanism, standardized query language, high query efficiency, and mature technology. Its representative products include Oracle, Microsoft SQL Server, and MySQL. When faced with big data computing problems, with large amounts of data and large amounts of unstructured or semi-structured data, relational database face the following challenges. First, large-scale petabyte-level storage management of big data requires that the system has good flexibility and can be easily expanded in a distributed environment. However, the traditional relational database emphasizes data consistency and integrity and centralized deployment methods, so its scalability is poor, and it is difficult to adapt to the explosive growth of data. Second challenge, RDBMS is suitable for storage management of structured data based on strictly defined key index and data table storage modes, and can provide an efficient SQL-based query mechanism. But for unstructured and semi-structured data, relational database is difficult to process and query efficiency is greatly reduced. The third challenge to the traditional database is big data calculation processing requires the storage structure to well support the upper-level calculation model. For example, the MapReduce calculation model adopts the divide and conquer strategy, which first divides a large dataset into multiple subsets, and then runs the map program for each subset for processing. After processing of the subset is completed. The reduce program runs to complete the summary of the calculation result, which requires the underlying data storage structure to support the division and fusion of this dataset. All data table structure. Due to strict data consistency and completeness requirements of a relational database, it is difficult to perform such segmentation processing on data tables. So it is difficult to support various calculation models for big data calculations. In recent years, non-relational databases based on distributed file systems that have emerged with big data processing, No SQL. Now, let's watch a video about how do No SQL database work.
NoSQL databases have become very popular. Big companies rely on them to store hundreds of petabytes of data and run millions of queries per second. But what is a NoSQL database? How does it work, and why does it scale so much better than traditional relational databases? Let's start by quickly explaining the problem with relational databases like MySQL, MariaDB, SQL Server, and alike. These are built to store relational data as efficiently as possible. You can have a table for customers, orders, and products, linking them together logically. Customers place orders, and orders contain products. This tight organization is great for managing your data, but it comes at a cost. Relational databases have a hard time scaling. They have to maintain these relationships, and that's an intensive process, requiring a lot of memory and compute power. So for a while, you can keep upgrading your database server, but at some point, it won't be able to handle the load. In technical terms, we say that relational databases can scale vertically, but not horizontally, whereas NoSQL databases can scale both vertically and horizontally. You can compare this to a building. Vertical scaling means adding more floors to an existing building, while horizontal scaling means adding more buildings. You intuitively understand that vertical scaling is only possible to a certain extent, while horizontal scaling is much more powerful. Now, why do NoSQL databases scale so well? First of all, they do away with these costly relationships. In NoSQL, every item in the database stands on its own. This simple modification means that they are essentially key value stores. Each item in the database only has two fields, a unique key and a value. For instance, when you want to store product information, you can use the product's barcode as the key and the product name as the value. This seems restrictive, but the value can be something like a JSON document containing more data, like the price and description. This simpler design is why NoSQL databases scale better. If a single database server is not enough to store all your data or handle all the queries, you can split the workload across two or more servers. Each server will then be responsible for only a part of your database. To give an example, Apple runs a NoSQL database that consists out of 75,000 servers. In NoSQL terms, these parts of your database are called partitions, and it brings up a question. If your database is split across potentially thousands of partitions, how do you know where an item is stored? That's where the primary key comes in. Remember, NoSQL databases are key value stores, and the key determines on what partition an item will be stored. Behind the scenes, NoSQL databases use a hash function to convert each item's primary key into a number that falls into a fixed range, say between 0 and 100. This hash value and the range is then used to determine where to store an item. If your database is small enough or doesn't get many requests, you can put everything on a single server. This one will then be responsible for the entire range. If that server becomes overloaded, you can add a secondary server, which means that the range will be split in half. Server 1 will be responsible for all items with a hash between 0 and 50, while server 2 will store everything between 50 and 100. Theoretically, you've now doubled your database capacity, both in terms of storage and in the number of queries you can execute. This range is also called a key space. It's a simple system that solves two problems: where to store new items and where to find existing ones. All you have to do is calculate the hash of an item's key and keep track of which server is responsible for which part of the key space. Now in this example, the range of 0 to 100 is a bit small. It would only allow you to split up your database into 100 pieces at most. So real NoSQL databases have much bigger key spaces, allowing them to scale almost without any restrictions. Besides great scalability, NoSQL is schemaless, which means that items in the database don't need to have the same structure. Each one can be completely different. In a relational database, you have to define your table structure, and then each item must conform to it. Changing this structure isn't straightforward and could even lead to data loss. Not having a schema can be a big advantage if your application and data structure is constantly evolving. Now at this point, it's clear that NoSQL databases have certain advantages over relational ones, but that's not to say that relational databases are obsolete. Far from it. NoSQL is more limited in the way you can retrieve your data, only allowing you to retrieve items by their primary key. Finding orders by ID is no problem, but finding all orders above a certain amount would be very inefficient. Relational databases, on the other hand, have no trouble with this. Now, there are workarounds for this issue, but only if you know how you're going to access your data, and that might not always be the case. Another downside is that NoSQL databases are eventually consistent. When you write a new item to the database and try to read it back straight away, it might not be returned. As I've explained, NoSQL splits your database into partitions, but each partition is mirrored across multiple servers. That way, a server can go down without much impact. When you write a new item to the database, one of these mirrors will store the new item and then copy it to the others in the background. This process might take a little bit of time, so when you read that item back, the NoSQL database might try to read it from a mirror that doesn't have it yet. Now, this is not a big issue in practice because data is replicated in just a few milliseconds, and if you want consistency, most NoSQL databases do have that option. So in summary, both NoSQL and relational databases will be around for the foreseeable future, each with their own strengths and weaknesses.
From the video, we understand how do NoSQL database work and advantages, disadvantages of relational database and also of NoSQL database. Non-relational database based on distributed file system have good scalability, can effectively process unorganized and semi-structured data, and support high concurrency. The characteristics of the calculation model have been widely used in the internet, medical and health, e-commerce, and other application fields. Compared with traditional relational database, this type of NoSQL database has the following common structure characteristic. The first one, no predefined data format is required. We don't need to define a strict data table structure in advance. Each record of data may have different attributes and formats. When inserting data, there is no need to define their format in advance. Second character, shared nothing architecture. NoSQL database often divide data set and store them on various local servers. The performance of reading data from local disk is often better than that of reading data through network transmission, thereby improving the system's read and write speed. A share-nothing architecture is a distributed computing architecture in which each update request is satisfied by a single node, processor memory storage unit, in a computer cluster. The intent is to eliminate resource contention among different nodes. The third character of NoSQL database, flexible and scalable. Nodes can be dynamically added or deleted while the system is running without downtime for maintenance, and data can be automatically migrated. The fourth character is partition, data partition. In contrast to storing data on the same node, NoSQL database partition data and distribute record across multiple nodes. In addition, Replication is usually performed at the same time as the partition, which not only improves parallel performance, but also ensure that there is no single point of failure. The fifth character, asynchronous replication. NoSQL replication is often a log-based asynchronous replication, so that data can be written to a node as soon as possible, rather than being delayed by network transmission. The disadvantage is that consistency is not always guaranteed. NoSQL database provides ultimate consistency. In this session, we learned what is NoSQL database. Thank you for your attention. If you have any question, feel free to contact me.